So in this video, you're going to learn how to add binary numbers. And the rules that you're going to learn are actually, you can apply them to binary numbers of any length. So if you had like a 20-bit number and a 20-bit number, you could use the same rules to quickly add those together. And it's a lot easier than many may think. For starters, you should, and I have to assume that you already know, what the value of each place on the binary number on a binary number is equal to. So we have the 1, the 2, the 4, the 8, the 16, and 32, 64, 128, and so on. And the reason that you need to know this is when you are adding a number like this, for example, this is going to be a 6. You got the 2 and a 4, so that's a 6. And this is a 1 and a 2, so that's a 3. You want to know that your answer should equal to 9. With that in mind, these are the rules. These 4 rules here. If you can remember these, you'll pretty much be golden. So if you have a 0 and a 0, and we add just like we would in the base 10 system from right to left. A 0 and a 0 is going to be 0. A 0 and a 1, you'll have a 1. A 1 and a 1 is going to be 1, 0. Now this one here, you'll put 0 and then carry a 1. You won't just put 10 underneath where you're working. And same thing here. If you get a carry of a 1 and it goes above a 1 and a 1, you'll end up with 1 and then a carry of a 1. And I'll show you exactly what I mean when I work out these examples here. So for this first example here, working from right to left, again, noting the places here, so we can see that this is a 6 and this is a 3. So our answer should be 9. So we have 0 and a 1, and according to our table here, that's going to be a 1. No carry. The next one, we have a 1 and a 1. 1 and a 1 gives us 1, 0. So we're going to put the 0, and the 1 gets carried. Again, a 1 and a 1. So we're going to do 1 and 1, and that gives us 1, 0. So we put the 0 and carry the 1 again. And here we have a 1 and 2 zeros, and that's just going to equal 1. You can check your work here too. Again, this is the 1's place, the 2's place, the 4's, and the 8. So we have an 8. I'm going to circle this here. We have a 1 in the 8 place and 1 in the 1's place. And that does give us 9. So it works. It works so far. So this would happen in a 3-bit adder here. Again, I'm going to write down what we have for our numbers here. This is a 6. We got the 2 and the 4, and then we got the 1 and the 2, so we got 3. So again, we should get 9. Same numbers, just looks a little different. This would be an example for a 4-bit adder, and this would be an example for a 3-bit adder. But you'll get to that later. Again, using the table, we got the 0 plus 1. That's going to be 1. 1 and a 1 gives us 1, 0. 0, carry the 1. Again, 1 and 1 and a 0 gives us 1, 0. So 0, carry the 1. Now this is interesting because we don't have anything to add it with. We just bring it down. In some problems, this is going to be considered something called an overflow, where the number is too large for the system. If this is a 3-bit system, 9 would be too large, where 7 would be the maximum number. 111 would be the maximum number. But you can see that this still works out to be correct. This is in the 8th place, the 8's place, and this is in the 1 place, so we have 9. This example down here, pretty easy. 1 and 0 equals 1. Same thing, same thing, same thing all the way down. No carries. Now if we look at this number here, it equals 15. And this number, of course, equals 0. Again, just recapping. And that does work out. This does equal to 15. It's a pretty easy one. This example here is going to be different from all the others because we're going to have the 3 1s in a row. So you'll see that in a second here. So 1 and 1 gives us 1 and a 0. So we put the 0 here, carry the 1. And now you can see we have 3 1s. And that gives us 1 1. So we put a 1 here and carry the 1. Now on this side we have 2 1s, 1 and 1. So we put a 0, carry the 1. And the same thing again, we have 2 1s, 0, carry the 1. And the 1 just comes down because we have nothing to add it with. And that would again be an overflow, but this, depending on how far along you are in your studies, this in some cases is an acceptable answer. This does work. And if you do the math, we have a 1, 2, and an 8. So that's equal to 11. We have the 1, 2, and the 4, and that's 7. So this should equal 18. And does it? We've got 1 in the 2's place and 1 in the 16 place. Add those together and you get the 18. So it does work out.